Chapter 2, Exercise 9. Hints. For parts A, B, and C, use definition 218 and theorem 219. For part D, also use theorem 223 and theorem 227. For parts E and F, look for non-empty sets with empty interior. Solutions. A. Let P element of E suck. There exists R greater than 0 such that this. We claim that this. Indeed, let Q element of NR of P. There exists epsilon greater than 0 such that this. For example, one can take epsilon equaling this. See the solution of exercise 6 or the proof of theorem 219. Hence, Q element of E suck and this. It follows that E suck is an open set. B. If E is open, then all points of E are interior points of E. Hence, E suck equals E. Conversely, if E suck equals E, then by part A, it immediately follows that E is open. C. Let P element of G. Since G is open, it contains a neighborhood NR of P. Hence, for some R greater than 0, we have this, implying P element of E suck. Therefore, G is subset of E suck. D. The inclusion E suck subset of E implies that this. Since the set E suck is open, part A, theorem 223, implies that E suck complement is closed. Then, by theorem 227c, we get this. On the other hand, the inclusion E suck subset of E suck bar implies that this. By theorem 223, the set here is open, then this by part C, hence this. Thus we include that this. E. No. Consider the real line R with the usual metric and let E equal Q, the set of all rational numbers. We recall that every neighborhood here in R contains a rational number distinct from X, theorem 120b. As a consequence, NR of X contains infinitely many rational numbers. It follows that every point of R is a limit point of Q, so Q bar equals R, and the interior of Q bar is R, since R suck equals R by part B. Now, take a positive irrational number alpha, for example, alpha equals square root 2. If A less than B, then there exists a non-zero rational number P such that this, by theorem 120b. Hence, interval AB contains the irrational number P alpha. This shows that every neighborhood NRX contains an irrational number, meaning it cannot be entirely contained in Q. Thus, Q suck equals empty set, while Q bar suck equals R. F. No. Again, consider the example E equals Q from part E. The interior of Q is empty. Consequently, Q suck bar equals empty set. On the other hand, Q bar equals R. Comments. This exercise tells us that the mapping interior defined by this is an idempotent operation here. Equivalently, E suck equals E suck for all subsets E subset X. Consider the mapping complement defined by this. In algebraic terms, the result in D states that the mapping's interior and closure are conjugate via complement here. Thanks for watching.